What if I told you that the farthest thing you could ever see with your naked eye on a perfectly clear night, standing anywhere in America, from the plains of Kansas to your own backyard, is so unimaginably far away that the light you're seeing left before humans even existed on this planet? That's not a riddle. That's Tuesday night in the universe. And here's the part that should keep you up at night. Scientists can measure it, they can map it, they can point a telescope right at it. But fully explaining why those distances exist the way they do, that's where things get beautifully, frustratingly wild. Hey, welcome back to Astromat, the channel where we take the biggest, most mind-bending ideas in space and physics and break them down so they actually click. I'm so glad you're here today because this one is genuinely one of my favorites. We're diving into the 10 craziest distances in space that stretch the limits of human understanding, and I promise you, if you stay all the way to the end, the universe is going to feel like a completely different place than it did when you hit play. Let's go. And if this is your first time here, hit that subscribe button, because we do this kind of thing all the time. Let's start with something that sounds simple, but absolutely isn't. How far away is that? It's a question you've asked your whole life. How far to Grandma's house? How far to the next rest stop on the interstate? We measure distance every single day without even thinking about it. You use GPS, you trust the odometer, you check Google Maps. Distance feels like one of the most reliable, settled things in human experience. Now throw all of that out the window. Because in space, measuring distance is one of the hardest unsolved problems in all of science. Here's why. On Earth, we can physically travel between 2 points and confirm the gap. In space, we can't do that. We can't send a tape measure to another galaxy. So instead, scientists built something called the cosmic distance ladder, a chain of measurement techniques, each one building on the last, each one reaching a little further into the universe. The first rung is the most solid. It's called parallax. Hold your finger up in front of your face and close one eye, then the other. Your finger appears to shift against the background. That shift tells you the distance. NASA and the European Space Agency's Hipparcos and Gaia missions used this exact principle to map billions of stars with stunning precision. Solid ground. Great start, but parallax only works close by. For deeper space, scientists use standard candles, objects whose true brightness they think they know, like Cepheid variable stars and Type 1a supernovae. By comparing how bright these objects should be to how dim they appear, they calculate distance. This is how Edwin Hubble first measured other galaxies. A discovery that rewrote our entire understanding of the universe. Here's where it gets uncomfortable. Every rung you climb on this ladder introduces new assumptions, new margins of error, new places where the model might be slightly wrong. And when you're measuring billions of light years, a small percentage error isn't small anymore. It's enormous. In fact, right now, 2 of the most respected NASA-backed measurement methods give different answers for how fast the universe is expanding. Scientists call this the Hubble tension. It isn't resolved. The ruler we use to measure the cosmos has a crack in it, and nobody yet knows exactly where the crack is. And that unsettling truth leads us directly into something even stranger. Because in space, every distance you measure isn't just a distance in space, it's also a distance in time. And that changes everything. Here's a thought experiment that I want you to sit with for a second. Imagine you're standing outside on a clear night somewhere in rural America, maybe out in the Texas Hill Country, or the high desert of New Mexico where the sky just opens up completely. You look up and you see a star, a single beautiful point of light. And you think, I'm looking at that star right now, in this moment, in real time. You're not. What you're actually seeing is a message that left that star years ago, sometimes thousands of years ago, and has been traveling across the void ever since, just to land on your eye tonight. The star you're seeing may not even exist anymore. It could have exploded centuries before Columbus ever sailed, and you'd have absolutely no way of knowing. This is the light travel trap, and it applies to everything we see in space, at every scale. Light travels fast, nearly 186,000 miles every single second. That's the ultimate speed limit of the universe, confirmed by over a century of physics and backed by every experiment NASA and the broader scientific community has ever run. Nothing beats it, nothing even comes close. But the universe is so incomprehensibly large that even at that speed, light takes real, significant time to cross it. When NASA's Hubble Space Telescope captured the famous Hubble Deep Field image, pointing at what looked like a blank patch of sky no bigger than a grain of sand held at arm's length, it revealed thousands of galaxies. Some of the light in that image had been traveling for over 13 billion years before it hit that telescope mirror. We weren't looking across space, we were looking across time. And here's the part that genuinely bends the mind. The universe has been expanding the entire time that light was traveling. So those galaxies aren't where they appear to be. They've moved. Some of them have moved so far that the address light gave us when it left is completely outdated by billions of light years. Distance in space and position in time are the same measurement wearing different names. Every single space discovery you've ever seen in a NASA image is a snapshot of a moment that no longer exists. We are, all of us, looking at a universe that has already changed. And that staggering reality becomes even harder to process once you understand that the universe isn't just expanding, it's accelerating away from us faster than you ever imagined. Okay, so we've established that the universe is expanding. You've probably heard that before. It's one of those science facts that gets mentioned so casually that most people just nod along and move on. But I don't want you to nod along. I want you to actually feel what that means. Because when you really sit with it, the expanding universe isn't just a cool space discovery. It is one of the most deeply unsettling things physics has ever confirmed about the reality we live in. Let's go back to Edwin Hubble. In 1929, working at the Mount Wilson Observatory in California, he noticed something that nobody expected. Distant galaxies weren't just sitting still in space. They were moving away from us, all of them, in every direction. And the farther away a galaxy was, the faster it was receding. This became known as Hubble's law, and it shook the scientific world to its core. Now here's the analogy that actually makes this click. Imagine you're baking a raisin bread loaf. Before it goes in the oven, the raisins are close together. As the dough rises and expands, every single raisin moves away from every other raisin. Not because the raisins are moving through the dough, but because the dough itself is growing. That is exactly what space is doing. Galaxies aren't flying through space like rockets. Space itself is stretching, and everything is being carried along for the ride. Now here's where it goes from fascinating to genuinely mind-blowing. In 1998, two independent research teams, both with strong American scientific involvement and later awarded the Nobel Prize in Physics, discovered that the expansion of the universe isn't slowing down the way gravity would suggest it should. It's speeding up. Something is pushing space apart with increasing force. Scientists called it dark energy, and to this day it remains one of the greatest unsolved mysteries in all of cosmology. NASA's WMAP satellite, and later the Planck mission, mapped the early universe in extraordinary detail and confirmed that dark energy makes up roughly 68% of everything that exists. We don't know what it is, we just know what it does. And what it does is deeply uncomfortable. Because here's the consequence nobody talks about enough. There are galaxies that were once close enough that their light could reach us, but the space between us and them is now expanding so fast that their light can never close the gap again. They are gone, not destroyed, just permanently, mathematically unreachable. Forever. Objects we could once see are being swallowed by an invisible horizon. And understanding exactly where that horizon sits leads us into the next and perhaps most confronting idea in this entire video. Let me give you a boundary, not a metaphorical one, not a philosophical one, a real, physical, measurable boundary that exists in space right now, one that defines the absolute edge of everything we can ever possibly know about the universe. Scientists call it the cosmic horizon. And what sits just beyond it is one of the most humbling ideas in all of space science. Here's how to think about it. Imagine you're standing in the middle of a vast, flat plain, somewhere like the Kansas prairie, stretching out in every direction as far as your eye can see. At some point, the horizon cuts off your view, not because the land ends there, but because the curvature of the Earth prevents light from carrying information any further to your eye. Beyond that horizon, the world keeps going. You just can't see it. The cosmic horizon works on the same principle, but the reason for the cutoff is far stranger. The observable universe, the sphere of space from which light has had enough time to reach us since the Big Bang, stretches about 46 billion light-years in every direction. Now, you might be thinking, wait, if the universe is only about 13.8 billion years old, how can we see 46 billion light-years? That's the expanding universe doing its work again. Space stretched while the light was traveling, carrying those distant points further away, even as their ancient light was still en route to us. NASA's WMAP and Hubble missions helped us map this boundary with remarkable precision. And what they confirmed is both exciting and sobering. The observable universe contains an estimated 2 trillion galaxies. 2 trillion. And yet that entire incomprehensible collection, every black hole, every star, every planet, every science discovery ever made, all of it fits inside a bubble surrounded by a wall we can never see past. Because beyond the cosmic horizon, space is expanding faster than light. Not faster than light moving through space, that would violate physics, but space itself stretching at a rate that outpaces the speed of light entirely. It's a loophole in the universe's own rulebook, and it means that whatever lies beyond that wall is not just far away. It is permanently, irreversibly invisible to us. And here's the thought that should genuinely stop you cold. The observable universe is almost certainly not the whole universe. It may not even be a significant fraction of it. The real universe could be unimaginably, absurdly larger than the bubble we're trapped inside, filled with galaxies and structures we will never detect, never study, and never name. We are not looking at the universe. We are looking at our tiny, privileged window into it. And when you push past even that window, when you look at the largest structures we can detect right at the edges of what's observable, the distances you find there don't just challenge our understanding of space, they challenge our understanding of physics itself. We've talked about distance ladders with cracks in them. We've talked about light that takes billions of years to arrive. We've talked about an expanding universe accelerating beyond reach, and a cosmic horizon we can never cross. Each of those ideas is genuinely staggering on its own, but now we go deeper. Now we look at the distances that don't just challenge our measurements or our telescopes. These are the distances that challenge the models themselves, the ones where physicists look at the data, look at each other and quietly admit, we don't fully have an explanation for this yet. Let's start with the largest known structure in the observable universe. It's called the Hercules Borealis Great Wall. It is a filament of galaxies so incomprehensibly massive that it stretches an estimated 10 billion light-years across. Let that number land for a second. 10 billion light-years. The entire observable universe is only about 93 billion light-years in diameter. This single structure spans roughly 1/10 of everything we can see, and that is a serious problem. Here's why. Our standard model of cosmology, the one built on decades of NASA data, the one confirmed by missions like WMAP and the Sloan Digital Sky Survey based out of Apache Point Observatory in New Mexico, that model predicts that at the largest scales, matter should be spread relatively smoothly and uniformly across the universe. Structures above a certain size simply should not exist. The universe hasn't had enough time since the Big Bang for gravity to pull matter into something that colossal. And yet, there it is. Then there's the CMB Cold Spot. Discovered in data from NASA's WMAP satellite, it's an anomalously large and unusually cool region in the cosmic microwave background radiation, the faint afterglow of the Big Bang itself. It is so large and so statistically improbable that standard cosmological models struggle to account for it naturally. Some scientists have proposed it could be the imprint of a supervoid, an enormous region of space nearly empty of matter. Others have suggested something far more radical, that it could be evidence of a collision with a parallel universe. That last idea has not been confirmed, but the fact that it is being seriously discussed by credentialed physicists tells you everything about how strange these distances really are. And this is the pattern that runs through every single one of the craziest distances in space. The numbers exist. The observations are real. The data has been checked and rechecked by some of the sharpest scientific minds on the planet. But the explanations, the clean, satisfying, complete explanations, are still being written. The universe is not waiting for us to catch up. It keeps revealing new edges, new anomalies, new distances that sit just outside the reach of everything we currently understand. And that, honestly, genuinely, is the most exciting place in all of science to be standing right now. So let's bring this home. We started today by asking a question that sounded simple. How far away is that? And what we found, layer by layer, is that the answer is one of the most complex, humbling, and genuinely thrilling frontiers in all of human knowledge. 3 things I want you to carry with you from this video. First, distance in space is never just distance. It is always also time. Every image NASA has ever captured, every galaxy Hubble has ever photographed, every light source you have ever seen in the night sky is a message from the past. We are not observers of the universe as it is. We are archaeologists of the universe as it was. Second, the universe has an edge we can never cross. The cosmic horizon is real, it is measurable, and beyond it space is expanding faster than light can travel. Whatever lies out there, and it is almost certainly vast beyond imagination, we will never reach it, never see it, never know it. And that is not a failure of science. That is just the shape of reality. Third, the largest structures we can detect, like the Hercules Borealis Great Wall, and the strangest anomalies we've found, like the CMB Cold Spot, sit right at the edge of what our best models can explain. The universe mystery is not behind us. It is directly ahead. And here is why this matters for all of us right now. NASA's Nancy Grace Roman Space Telescope, currently in development, is designed to map the universe at a scale we have never attempted before, probing dark energy, measuring cosmic distances with new precision, and pushing the boundaries of the observable universe further than any American space program ever has. The next chapter of these answers is being written by scientists and engineers working right now, today, in laboratories and clean rooms across the United States. We are living in the most extraordinary moment in the history of space exploration. The tools are getting sharper, the data is getting deeper, and the questions, beautifully, stubbornly, keep getting bigger. Here is your final thought to take into the rest of your day. You exist on a small, rocky planet, orbiting an ordinary star, sitting in the outer arm of one galaxy, among 2 trillion. The light reaching your eyes right now has crossed distances so vast that the sources that produced it may no longer exist. You are surrounded on every side by a cosmos so large that our observable universe, with its 2 trillion galaxies and every science discovery ever made, may be nothing more than a single grain of sand on an infinite beach. And somehow, improbably, beautifully, you understood it a little better today than you did before you pressed play. That is everything. That is all of it. That is why we do this. If this video gave you that feeling, that electric, quiet awe of the universe clicking into focus just a little more clearly, then hit that subscribe button right now and come back every single week. Because here on Astromat, that feeling is exactly what we show up to create, every video without exception. New videos drop every week. The universe is not going to run out of things to show us, and neither are we. Hey, thank you so much for watching this one all the way through. It genuinely means a lot, and I hope that idea really landed for you, that every single time you look up at the night sky, You are not seeing the universe as it is right now. You are seeing deep into the past. That one shift in perspective changes everything. As NASA pushes forward with new missions designed to map the cosmos further than ever before, these aren't just abstract science facts. They are the questions that will define America's next era of space exploration and our understanding of where we all came from. I love getting to explore this stuff with you. Honestly, there is nothing better. I'll see you in the next one.